Uh, yeah, I guess we can start. So, can you please confirm whether am I audible or not? Because there's some issue with my microphone, so it will be like.
Yeah, there's some little noise in the microphone. Otherwise, it is okay.
Yeah. So just like it will be for the initial part. So my microphones are charging. So meanwhile, like I connected with different source. So I think we can proceed with that if it's fine with you. Yeah. So good evening, all. Welcome to week 7 session for this particular NPTEL course, which is NOC 25 C115 Ground Improvement. Myself, Rituraj Siswal. I am currently working as Prime Minister Research Fellow in Department of Earthquake Engineering from IIT Roorkee. This course is currently being tutored by Professor Dilip Kumar Bedia, who is Professor in Department of Civil Engineering from IIT Kharagpur. Uh, so, those who have joined this session for the first time, let me tell you. So, these sessions are meant to interact with our learners. We will be discussing some of the important concepts which will be required to solve some of the assignment problems. We'll also be solving some of the sample questions which will be helpful to you to solve that particular week's assignment problem and also to understand the concepts related to the lectures covered in that particular week. We'll be solving some of the doubts, like if you have any. Apart from that, if you have any other query which you want to discuss other than the course, like the career guidance, or if you want to understand some another soft skill which you think can be helpful in covering this course, so we'll be happy to help you if if it covers under our extent. So please feel free to interact with us. So let's start with our today's week, our this week's sample questions. So currently, this week lecture was being covered on the pre-consolidation or the pre-vertical drains. So we'll be discussing some of the concepts related to or some of the sample questions related to that particular part. So we can start. So yeah, here is your first question. So you need to calculate the time factor for degree of consolidation more than 60%. So there's straightforward formula. So you need to select with that. I think the answer is already displayed on the screen. But yeah, you can cross check with your lecture notes. So which one of the particular empirical relation which we usually go for while calculating the time factor. Yes, so the answer is straightforward. The time factor for the degree of consolidation more than 60%. So this is a particular empirical relation. So the option C we usually go for, like whenever the degree of consolidation is greater than 60%, then we go for C. So yeah, and usually when the degree of consolidation is less than 6%, so there's a different empirical relation which you'll see in like upcoming questions. So that's straightforward. I don't think there can be any doubt. If you have any, please feel free to discuss. Okay, then let's move to question number 2. Yeah. So, what is the correct statement regarding the rate of consolidation? So you need to select which is the correct options about the rate of consolidation. You need to select one correct statement. Yeah. So let's check the answer. Yeah. So we know there's a relation between the time factor as well as the time of drainage and the rate of consolidation. So we know TV is equals to CVT by D square, right? So you know your time of drainage depends on the square of length of drainage path. So your T is directly proportional to D square. That's why your rate of consolidation, like how fast is your consolidation is happening. So that time basically depends on the square times of D. So the correct option is B, directly proportional to the square of the length of the drainage path. Let's move to question number two. Question number third. So you need to determine one of the option. So the permeability in the smeared zone compared to unaffected soil. So how much is your permeability in the smeared soil? First of all, you need to see what is the smeared zone is. Yeah, so let's check the answer. Yeah, so the correct answer is less. Uh, so we can understand about understanding what is basically smell zoning. So usually, like to increase the rate of drainage in your ground, you basically insert the pre-vertical drains. These pre-vertical drains basically accelerate the dissipation of the excess pore water pressure, and thus like it helps in ground improvement technique by uh, providing the increment in the drainage path. So what basically happen as soon as you insert this uh, vertical drainage into the soil, there is a increase in confinement of the soil, and due to that increment in the confinement of the soil, like and this confinement happens to a certain area which is surrounded by near your pre-vertical drain, and as soon as your confinement increases around the pre-vertical drain, so you can observe that like there is a reduction in the permeability, because since the particle realignment has been taken place over there, and due to that you can observe that there is an increment in the confinement, and thus your permeability basically reduces. So this region where you can observe the increment in the decrement in the uh, permeability, this the region is known as the smear zone, and by its very definition we can check that in this particular region your permeability basically decreases. Hence you can see that there's a less, the permeability in this measure compared to unaffected soil is less. So, so moving to next question, question number 4. Yeah, so here you need to calculate the ratio of the permeability coefficient Kp by Kr. So you have been given with the properties of a fine grained soil sample P, which is having the coefficient of volume compressibility MV is equals to 3.6 into 10 raised power minus 4 meters square per kilonewton, and coefficient of consolidation CV is equals to 4.2 into 10 raised power minus 4 centimeters square per second. The properties of fine grained soil sample R is having coefficient of volume of compressibility MB is equals to 2.6 into 10 raised power minus 4 meters square per kilonewton, and the coefficient of the consolidation CV is equals to 2.25 into 10 raised power minus 4 centimeters square per second. Then you need to evaluate the ratio of the permeability coefficient, which is Kp by Kr. So you need to determine what is the ratio of the permeability coefficient Kp by Kr. So Kr is your permeability in radial direction, and Kp is your permeability in another direction.
Yeah, so let's
Yeah,
check the
so let's
answer.
check the answer.
So answer is 2.6. So we need to evaluate what is Kp by Kr. So that depends on the ratio of your in your radial direction. Okay, that is your Kp by Kr. So that is not the permeability in two direction, rather it's permeability of two samples. So it depends on the ratio of your mv to cv, and here your mr to mp to cvp, and here your mbr to your cvr. So that two ratio basically determines the ratio of the permeability coefficient. So let me show you what is the formula for permeability anyways. Yeah, so it depends on the ratio of Kp by Kr. So your MVP is your 3.6 into 10 to the power minus 4 meter square per kilonewton into your CVP, that is your 4.2 into 10 to the power minus 4 centimeter square per second, then your MVR into CVR. So your MVR is 2.6 into 10 to the power minus 4 meter square per kilonewton into your CVR. So I know there are some ambiguity with the units, but since we are taking a ratio, so that can be handled accordingly. So let's check the answer for this. Yeah, so the answer is 2.58, which is proportional to 2.66. Yeah, so the correct answer is option C. uh, the ratio of the permeability coefficient Kp by Kr is 2.6. Let's move to question number 5. So in the question number 5, you have been asked, under a specific loading condition, a saturated fine grained soil layer experiences 35% consolidation within 185 days. The additional duration which is required for a further 18% consolidation will be. So you have been given a saturated fine grained soil which experiences 35% consolidation within 185 days. Now you have been asked what is the additional duration, the additional time which is required to cause further 18% consolidation. So it's an interesting question. I request you to please attempt this. Yeah, so let's check the answer for this. So the time factor is given by equals to CVT by D square. So your time is directly proportional to TV. Also, you know that time factor is also directly proportional to your degree of consolidation, that is U. So your U is directly proportional to, okay, T is directly proportional to U square. So your T is directly proportional to U square. So if I want to calculate, so once you want to calculate what is the degree of consolidation after 185 days, so degree of consolidation corresponding to 35%, and then you need to calculate the degree of consolidation which is 53%, 35 plus 18, right? So that is u35 square, u53 square. So that is corresponding to the time required for 35 square and time required for 53 square. So for t53 square, your value will be t35 square into u53 square upon u35 square. So your t35 square it takes 185 days, right? And degree of consolidation for u53 is 0.53, so that will be 0.53 square, and for 35 it's 0.35, so that is 0.35 square. So if I take this, so if I calculate this, what is the t53? So let's evaluate this. So 185 into 0.53 square, answer divided by 0.35 square, root over answer. Yeah, so the t53 value you will get, it's 21 days. I think there is some, okay, this is not 35 square, so 185 into 0.53 square. Yeah, so t53 is your 424.16. So if I check this, so for the time required for further 18% consolidation will be your 424 minus 185 days, which is none other than your 239 days, right? Yeah, so the correct answer is option C, 239 days. So let's move to question number 6. Yeah, so you need to select the correct statement about the preloading. So which statement reflects the correct statement about the preloading? Option A is looking for use for low permeable geometry, does not work well within constraint areas, both A and B, or D, none of the above. Yeah, so you need to select the correct statement about preloading. Yeah, so let's check the answer. So correct answer is both A and B. So preloading is a certain type of process where you basically enforce the settlement in this your ground by imposing external load, so that after your construction is over, that enforced loading over your soil, so that your enforced loading over the soil basically uh, cause the required settlement which need to be happen in the ground, and so that you don't observe the settlement in your structure, in your superstructure after it has been put. So definitely it is usually used for the low permeable geomaterial, uh, and it does not work well within the constrained area, because if it is constrained from the end, so you can't see the required uh, decrement in the volume, because it has been disturbed. So it is usually used for low permeable geometry, and it does not work well within the constrained area. So your correct answer is both A and B. Moving towards the next part of the question. Yeah, any doubt in this? So first of all, it does not work well within the constraint area, and we usually go for the low permeable geomaterial. Uh, if it's a highly permeable geomaterial, so in that case, basically we go for the pre-vertical drains to enforce the drainage. Moving to question number 7. Yeah, so you are given the prefabricated vertical drains which were installed in an 11-meter thick layer of compressible fine grained soil arranged in triangular formation with a 2.8 meter space between each drain. The PVDs used had a width of 113 mm with a thickness of 5 mm. The coefficient of the conservation of the fine grained soil in the horizontal and vertical directions are 3 meter square per year and the 4 meter square per year respectively. The boundary flow below the fine grained soil layer was impermeable. Yeah, so there is a problem related to the pre-vertical drain which is installed in an 11-meter thick layer of the compressible fine grained soil. This is arranged in a triangular formation with a 2.8 meter space between each drain. So your space between each drain is 2.8 meter. The PVDs used had a width of 113 mm and it has a thickness of 5 mm. The coefficient of the consolidation of the fine grained soil in the both the direction are given 3 meter square per year and 4 meter square per year. The boundary between the fine grained soil layer was impermeable. So your boundary just below the fine grained soil layer was impermeable. So yeah, first it has been asked what is the equivalent diameter of the pre-vertical drain based on equal perimeter of the PVDs. So you need to determine the equivalent diameter of the pre-vertical drain, which is measured in mm based on equal perimeter of the PVD. So let's check the answer. So the correct answer is 75.1. So in this you are having a p-vertical drain. So it has been given the two dimension. So the width is none other than 103 mm and your thickness is 5 mm. So the equivalent diameter of the p-vertical drain, yeah. So it is none other than your pi d 2a plus b, because your one dimension 113 mm, another dimension is 5 mm. So pi 3.14, your diameter is 2 into your a is 113 plus 5, and then you have been asked to calculate the equivalent diameter, so that we need to determine. So your d is 2 into 113 plus 5 into 3.1. So the correct answer which I am getting right now is 75.15. So the most closest option is option C, which is one of the correct answer. The next you have been asked to calculate the value of consolidation time factor. So T for horizontal flow in 2 years time, please. So you need to calculate what is the time factor for horizontal flow in 2 years time. Hello. Yeah. So guys, let's check the answer. So first you need to evaluate what is the number of drains you require. So that can be calculated by n by d by dw, where d is none other than your equivalent diameter. Your equivalent diameter can be obtained for the triangular pattern as 1.05 times of its spacing. This is uh, your spacing you have given as 2.8 meter. It is 2.94 meter. Right. Yeah. So that is the equivalent diameter. So your n value is d, which is 2.94. dw is your 75.1. So that is meter, and need to multiply by 10 raised to power 3. So 2940 divided by 75.12, 39.14. So now you have been asked to calculate the time factor for radial flow. This can be calculated by TR, and you have been uh, given with a coefficient also. So CRT by D square. So you, in the radial direction, is 3 meter square per year, and time is given at 2 years, and T equivalent you need to take into account, so that is the drainage part. So 2.94 whole square. Yeah, so that will come out as 6 divided by 2.94 square, which is 0.694. So your time factor in the radial flow is TR is equals to 0.69. So the correct option is option C. Moving to question number 9. Yeah, in question number 9 you have been asked the prefabricate vertical drains for. Okay, you need to evaluate the degree of the consolidation due to drainage in radial direction only in 2 years time. So first you have calculated TR. Now you have to evaluate your degree of consolidation in the radial direction only. So you can take the help of this TR only, then you can evaluate this. So there is a certain formula which you need to consider. Just check that. आठ बजे आता हूँ. अच्छा, आपका कुछ रूम में रख दिया था मैंने. अच्छा. बताओ बताओ। अच्छा, क्लास ले लेते हैं बस, क्लास चल रहा है। हाँ, दे रखा है, कर रहे हैं। मतलब बीच बीच में आते बच्चे जाते जाते हैं। एक्चुअली रिकॉर्डेड डालता हूँ तो
ये रिकॉर्डेड है?
मतलब मैं रिकॉर्ड क्या लगा परफ्यूम।
कैसा है?
ठीक है, अच्छा
अच्छा है, मेडिसिन।
शायद।
वो फिर
अपन को तो कल मिलने के लिए बोला ना,
हाँ?
अपन को तो कल
अरे सर, क्या हाल है? क्या
पहले
भाई,
आए।
कहाँ इतना तुम बिजी हो? ये चालू हो गया क्या?
कुछ नहीं, बच्चे नहीं आज
क्या
रिकॉर्ड
बात
करके
है?
डाल रहा हूँ मैं, क्वेश्चन सॉल्व करके बस।
हाँ, क्या कहाँ इतना बिजी चल रहा है?
मैं तो लैब में रहता हूँ।
अच्छा,
आपका बिजी चल रहा है, मुझे
मैं तो
रिवर्स क्वेश्चन पूछूंगा।
तभी मैंने पहले ही पूछ दिया। लेकिन
स्मार्ट।
देवेंद्र का कॉल आया मुझे, उसको कुछ पूछना था।
बताइए,
तो
आपने
मुझे
बता दिया, आपने बता दिया।
क्या हो गया सर, ऐसा क्या है, क्या प्रॉब्लम है, आप बताओ। हम मारेंगे, किसको मारना है? अमित कौन है?
हाँ, ये नहीं पूछना था कौन है, मुझे मारेंगे।
नहीं नहीं, तो मारेंगे, जाने बिना मारेंगे कैसे हैं? जाने बिना मारूंगा कैसे? क्या मारूंगा? अमित नाम से तो बहुत लोग हैं, अमित शाह को बोलो तो भाई थोड़ी मार दूंगा मैं अमित शाह को। जिंदा भी तो रहना है।
अमित कानविंद है वो।
कानविंद है, उसको थोड़ी मारूंगा भाई, पीएचडी भी तो करना है।
क्या बता, थीसिस उसके पास चले जाए।
हाँ, फिर बताओ। क्या हो गया, एक्सपेरिमेंट में प्रॉब्लम? अरे वो सेंसर इस जगह दिए उसने, सारे खराब, कोई काम नहीं करेगा। अच्छा, अब क्या लिख के भेज रहा है कि सेंसर आप टेबल पे चेक कर लो, अगर वो काम कर रहे हैं तो उनसे काम करो। भाई तुझे
क्या बोल रहा?
एप्लीकेशन टेबल पे रख के आपके, अगर आपका एक्सपेरिमेंट चल रहा है तो वो आपके एक्सपेरिमेंट सेटअप में देखो आपको क्या करना है।
तो तेरे सेंसर की वजह से हमारे
नहीं,
ऑब्जेक्टिव थोड़ी चेंज करेंगे।
भाई तुझे बता दिया है कि इस एक्सपेरिमेंट सेटअप के लिए तुझे ये तो नहीं कहा कि हमें ये चीज़ चाहिए, तुझे ये बताया कि इस चीज़ के लिए, इस एप्लीकेशन के लिए ये चीज़ चाहिए। एप्लीकेशन बेस्ड काम बताया। तेरी सजेशन गलत, एक जगह बफर खो चुकी है, इससे भी हो गई गलती तो फिर लॉगर लॉगर सब लौटेगा।
ऐसा मत कर रहा है।
मैं कब कर रहा हूँ, मैंने सोचा इस तरीके
नहीं,
से
आई
करना है
गेस
अगर।
उसका वो होगा, उसका थोड़ा वो है ना कि ऑन रिकॉर्ड आ गया, बातों में तो हेलो हेलो कर रहा था, पर अब इसको वो रिकॉर्ड में
अगर
वो
ऑन रिकॉर्ड तभी तो कहा है कि ऑन रिकॉर्ड है बात। अपडेट ऑन सेंसर को खा गया।
सर को बोलो भाई,
भाई मैं चलता हूँ, थोड़ा खाना है।
कर लो सर, कर लो।
मिलते हैं सर। क्या वो मारने की बात कर रहे थे ना?
वो होता है वो वाली बात है अभी, रोज मकान में उठते गिरते हैं।
इसलिए मुझे थोड़ा फीलिंग भी नहीं है। चलो ठीक है, मैं एक्सपेरिमेंट कर लूँगा अगर उसके। मैं इतने दिन वेट ही क्यों करा मैंने। और ये कि अभी तक तुम वो चीज़ नहीं प्रोवाइड कर पा रहे हो, सोल्यूशन नहीं प्रोवाइड कर पा रहे हो, फिर आप डाल देगा हम मदद करो। तो अगर बात बढ़ जाएगी तो फिर बाकी चीज़ों के बाद मसला आएगा, हमारे बाकी काम भी रुक जाएंगे।
चेक इंक्लाइन करके चेक नहीं करेगा तुमने?
बात इंक्लाइन करके चेक करने की नहीं है सर,
वो
बात ये है कि
वो
इंक्लाइन
नोट
जो
ही
है
नहीं कर रहा है वो।
वो उसकी, जहाँ तक मुझे लग रहा है उसकी सेंसिटिविटी का इशू है।
वो एक्टिविटी एक थोड़े टाइम के बाद होता
वो
होगा।
सेंसिटिव नहीं है इतना। भाई 200 किलोग्राम का है तो अगर 2 किलोग्राम आ रहा है तो वो नहीं कर पाएगा। हमने पहले वॉल्यूम ज़्यादा रखी थी क्योंकि बेड भी आएगा, बेड के ऊपर से फिर और लोड आएगा, तो इसलिए 200 किलो के आसपास रखा था। तो 1 टन के हिसाब से लोड भी चला रहा था मैं। अभी मैं टर्म चालू की थी, लेकिन बात ये है कि वो लोड कैप्चर करना चाहिए क्योंकि उसकी एक्यूरेसी लिख रखी है, वो तो करे काम। ओवर प्रेशर में भी इसने यही मैनिपुलेट किया, कहने लग गया 0.2 बार का था। मुझे भी नहीं पता था यार, मैं ही तो पता होता।
यार सर मुझे वो लगता है ना कि थोड़ा वो चीज़ एक्टिवेट होने में ही टाइम लगती है। जैसे अपन वेइंग मशीन में भी खड़े होते हैं तो वो एकदम से चालू नहीं हो जाता, वो दो
नहीं नहीं
तीन
नहीं,
चार
मैं
पाँच
मेरी
सेकंड के
देखूंगा
बाद
ना,
चालू होता है।
मेरी रीडिंग देखूंगा, हाँ ये भी हो सकता है।
तो आपका डेटा ही 4-5 सेकंड के बाद रिकॉर्ड होना चालू हो रहा है जब तक आपका एक्सपेरिमेंट खत्म हो
मेरी
जाएगा।
रीडिंग में -1.5 से शुरू हो रही है रीडिंग, नॉर्मल की, शेयर की नहीं,
हम्म,
नॉर्मल की -1.5 से शुरू हो रही है। अच्छा, दूसरी एक चीज़ और भी है, इसने जिस तरीके से बनाया है और जो ट्राइएंगल लोड सेल होता है एक्चुअल, उसमें इसमें बहुत फर्क होगा मुझे लगता है। इसने तो दो स्ट्राइक लोड सेल ऐसे और ऐसे लगा दी, और जो लोग ट्राइएंगल बनाते होंगे वो कैसे बनाते हैं, वो तो एक पूरी टेक्नोलॉजी है ना 8 लाख रुपए में।
नॉर्मल आ रहा है आपका शेयर।
नॉर्मल, नॉर्मल में पहले आया -1.5, फिर -0.5, फिर 0। मुझे लगा नॉर्मल लोड आ गया, ठीक है, नेगेटिव आया पॉजिटिव आया डजेंट मैटर। फिर जब मैंने टाइम स्टेप चेक किया, वो रैंडम आ रहा था कि शुरू में लोड सेल, मतलब स्टार्ट टैग स्टार्ट करते टाइम -1.5 -0.5, जिस
क्या
टाइम
आता
पे
है?
लोड आया है ना उस टाइम जीरो ही है।
केजी आता है? क्या आता है?
हाँ,
क्या आता है?
केजी आना चाहिए या फिर जो भी आ रहा हो, किलो न्यूटन आ रहा हो, केजी आ रहा हो, वॉट, केजी में आता है वैसे। वो
बात
निकल जाएगा। अब कल सब अगर आए सबको मैं बताऊंगा, तो सब गुस्सा करेंगे, सब गुस्सा करेंगे, फिर ये हुआ कि बाकी सेंसर भी चाहिए, ये फिर उसे बुलाया जाएगा, फिर एक
नहीं,
बवाल हो जाएगा।
ज़्यादा गुस्सा मत
हाँ,
करवाना। ज़्यादा गुस्सा मत करवाना।
वही तो बात है ना
और
यार।
प्यार प्यार में ठीक है, 10-15 दिन लेट दे नहीं दे फिर तो भी
सर
ख़त्म हो
ऑलरेडी
जाए।
बहुत इसको बोल चुके हैं, कहने देखो अमित जी, मैं तो वैसे ही आपसे बहुत वो पहले भी आपसे आपका एक्सपीरियंस खराब है, लेकिन ये मैं वही तो उसमें आ गया हूँ यार, बाकी चीज़ें तो ही दूसरी हुई हैं। चलो, हाँ वालेकुम सलाम। हाँ जाऊँगा जाऊँगा, चलिए निकाल दूँगा, दिक्कत नहीं है। मैं ठीक है यार।
ठीक है।
तुम्हारे का भी क्या कह रहा है वो?
मेरा तो
तुम्हारी तरफ से क्या क्या चीज़ नहीं दी उसने अभी?
और तो मुझे एक्सपेक्टेशन है ही नहीं, एल्गोरिथम में इनसे जुगाड़ूंगा।
एलवीडीटी नहीं दिया उसने अभी तक ना,
वो देगा भी नहीं मुझे।
और इंक्लाइनोमीटर भी नहीं दिया उसने कोई,
इंक्लिनोमीटर एक्चुअली डिपार्टमेंट में कहीं नहीं है, तो
कहीं नहीं है।
जक्का सर की लैब में पर खराब है।
मतलब कहने का मतलब ये कि अगर सर पूछेंगे तो बताना पड़ेगा ना कि इंक्लाइनोमीटर दिया था वो ख़राब निकला, और लोड एलवीडीटी दिया नहीं है अभी इसने।
एक्चुअली बाकी सब तो वो है ना कि अब तक वो ऑर्डर पीओ निकला नहीं तो अपन कैसे एक्सपेक्ट करें उस चीज़
वो एक
को। पर
अलग
वो
चीज़ है। आप तो ये क्लेम कर रहे हो ना कि मैं दे दूंगा आपको इतने दिन में, आप ये कहो कि सर पीओ दे निकलेगा उसके बाद ही दूंगा, कोई कुछ नहीं बोलेगा। ये आप कह दो कि पीओ निकाल दो आज, मैं आपको इसके 2 हफ्ते बाद दूंगा, 3 हफ्ते बाद दूंगा, ऐसे थोड़ी नहीं होता यार। फिर पीओ तो आप नॉर्मल पीओ निकालो, इंक्लाइनोमीटर उसके तो तुम्हारे नॉर्मली निकल जाते बगैर उसके टेंडर के।
नहीं, बट बात वो है ना कि फिर वो कुछ कार्रवाई करनी है तो इस रिकॉर्ड को, हाँ मतलब डांट तो
पीओ
सकते हैं अपन बात तो
पीओ
कर।
अगर आप निकालोगे,
पर फिर वो एक्सट्रीम फाइट पे जाएगी तो वो उस चीज़ में फिर वो डॉक्यूमेंटेशन वाली चीज़ है
मैं
तो
वही कह रहा हूँ, हम फंस रहे हैं ना, मेरे भी तो अब जैसे बहुत सारी चीज़ें हैं। अब मैंने अब इसको एक चीज़ और बनने को दे रखी है, सेंसर दे रखे हैं उसके लिए, इसका पीओ नहीं बना। अब ये आएगा तो फिर इससे बात करनी पड़ेगी कि भाई ठीक है पीओ बनवा रहे हैं, ये चीज़ें हैं, आप बैठो, वहीं सर के ऑफिस में बैठ के इसको लिखवाऊंगा कि क्या आई डोंट नो, यू हैव टू सजेस्ट एंड दिस हैज टू वर्क। आई डोंट नो व्हाट इज नीडेड, यू आर टेलिंग मी दैट दिस इज नीडेड, यू आर सजेस्टिंग द प्रोडक्ट, दिस विल वर्क फ्रॉम योर एंड, वी डोंट नो व्हाट यू आर डूइंग।
स्पेसिफिकेशंस थे ना, रोड सर का टेंडर निकला था पहले।
सर की तो रिकॉर्डिंग रहेगी ना, सर के पास रिकॉर्डिंग है, वो
तो
रिकॉर्डिंग।
आप एटलीस्ट उसको स्पेसिफिकेशन जो दे रखे हैं ना कुछ तो वो भी मिसमैच हो रहा होगा। तो उस वो जब बोले ना कि मेरी तरफ से तो सब चीज़ें रेडी है, तो उसके आप 3-4 पॉइंट ऐसे पकड़ लेना कि आपकी स्पेस में ये ऑर्डर चाहिए, ये तो हो ही नहीं रहा। ठीक है, मतलब मानो कि मेरा एक्सपेरिमेंट नहीं हो रहा, बट आप जो कह रहे हो वो भी तो नहीं हो रहा।
नहीं, मेरा पॉइंट टू बार वाला लोड सेल बिल्कुल सही काम कर रहा है। वो पॉइंट टू बार वाला प्रेशर काम कर रहा है, उसने दिया, रीडिंग दिए, इसका वाला नहीं चल रहा, इसके वाले दो हैं मेरे पास।
हाँ, तो इसके स्पेक्स से तो मुझे पक्का पता है कि इसके अगर 10 स्पेक्स इसने दिए तो 10 के 10 तो कभी मैच होंगे।
कभी मैच होते नहीं
तो
है।
अपन ना पहले उसको उस चीज़ पर अटकाएगी जिस पे ये अपन को बोल रहे हैं ना कि मैं अपने इस एंड से सही हूँ, तो बोले कि पहले तो आप इस एंड पे सही नहीं हो, और दूसरा तो हमारी तो रिक्वायरमेंट ये है, पर आपने जो बोला वो भी मैच नहीं होगा।
मैं ये नहीं चाह रहा कि आप इसको मतलब इसका काम नहीं लें इससे कुछ, बस मैं ये चाह रहा हूँ कि अब ये जो चीज़ें हमारी हैं वो तो सही करके दे दे ताकि हमारा काम चल जाए। तपन के साथ
हो ही नहीं रही होगी सर
हाँ,
सर हो ही नहीं रही होगी सर, वो वाली
बात सारी है ये पता है, ये
और
आके ना बोल देगा ये मैं ये कर दूंगा। अब ये लोड सेल बनाया है, मुझे गारंटीड ये लोड सेल 2 एक्सेस लोड सेल का डिज़ाइन है ही नहीं, मुझे 3 एक्सेस पे जो होता होगा मैं अब चेक करूँगा अगर मुझे कहीं मिल गया तो। अब मैं उसको देखूंगा, इसको देखूंगा, फिर मैं उससे बोलूँगा इसको कि साले ये क्या बनाया है, लोड सेल यूँ लगा दिया यूँ लगा दिया, कि ऐसे तो तुम अलग अलग लगा दो लोड सेल, 2 एक्सेस थोड़ी नहीं हो गया।
करते चल चलता। हेलो, या गाइस, सॉरी फॉर डिले. So we need to calculate the degree of consolidation percentage due to drainage in radial direction. So for that we need to calculate the Fn value. So Fn value is a function of your number of drains. So which is basically given by ln of n minus 0.75 39.14 minus 0.75, which is none other than 2.9, right? So your TR value should be CRT by T square, sorry, so now you need to calculate. So the degree of consolidation can be calculated by 1 minus exponential minus 8 by TR f of n. This is your 1 minus exponential minus 8 by TR. Your TR value is 0.694 and your Fn value is 2.9. So that is coming out as a 0.85, which is 85%. So your correct answer is option C. Sorry. Yeah, the answer is 85 only. The marked option is wrong here. So C is 85. Okay. So the degree of conservation due to drainage in radial direction in 2 years time is 85%. Moving to question number 10. So assuming the estimated ratio is 3, the horizontal coefficient of the consolidation of estimated soil is 2 meter square per year, which is kh by kx equals to 3. The time factor due to radial flow in 2 years time. So you need to calculate what is the time factor to radial flow in 2 years time. So for attaining this question, you need to use the same formula, which is the time factor formula, which is CRT by d square. Your CR value, which you have calculated, for the smash zone is given as 2, and the we know is 2.94 square, and it has been asked in 2 years time, so that is a part. So 4 upon 2.94 square. So the correct answer of TR is 0.463. So the time factor T due to radial flow in 2 years time is given as 0.463. Moving to next question, question number 11. So yeah, you need to select the correct statement. The following statements are which are connected to ground improvement by preloading technique. So the statement A is preloading is specially used for low per meter geometry. We have seen that in previous question. Preloading can be easily implemented in open land with limited resources. The basic concept of preloading is to reduce the void ratio of geometry through consolidation. So let's check this answer. Yeah, so let's check the answer in this. So the correct answer is ABC. Yeah, so as we have seen in previous also, this preloading is basically being used for low permeable geomaterial. We can easily implement this in an open land with limited resources, so it's an easy ground improvement technique. And yeah, the basic concept is to reduce void ratio of geomaterial through consolidation. So usually for low permeable geomaterial where the dissipation can't happen due to some external source, we use the external loading to dissipate the excess water pressure, and we use that technique as the preloading technique. So the correct option is option A. Moving to question number 12, you need to select the correct external again. So the statements are that during the installation of the vertical drain, the surrounding around the drains is disturbed. Coefficient of the consolidation in the smelt zone is reduced. Coefficient of the permeability in the smelt zone is increased. So you need to select one of the option about the smell effect. मेरी क्लास चल रही, बताओ जल्दी क्या हुआ? भाई मीटिंग में था रे। हाँ मीटिंग में हूँ, बताओ। कोई नहीं, कुछ नहीं, मीटिंग में था। चलो बाय। Yeah, so let's check the answer. So correct answer is option A and B. So as we have seen, like in a ground when we insert a pre-vertical drain, so usually the region around the pre-vertical drain is disturbed. Yeah, so the surrounding around the drains is disturbed. Your coefficient of consolidation of a smear zone is reduced. Yeah, so your speed will reduce, and the coefficient of the permeability in the smear zone is increased. So that is not the case because option B is correct. So your only option is option A and B. Yeah, now you need to select the formula for degree of consolidation, correct formula, which is less than 60%. So earlier we have selected the option which is greater than 60%. Now you have to select the option less than 60%. So again, it's a straightforward question. You if you'll go to the if you'll go to the lecture notes, you will understand what is the correct relation. So the correct relation is option A, which is CV is equals to pi by 4 u square. Again, this is a repeated question, so yeah, it's proportional to the square of drainage path. Yeah. Now you need to select the correct statements about the preloading. Yeah, so let's check the answer. So correct answer is all of the above. So the correct statement above the preloading. The limitation of the preloading is longer time required for consolidation. If vertical drains are used, preloading require high head space for installation. Yeah, that's correct. Yeah, you need a high head space to insert the pre-vertical drain. Yeah, so you can't use it in the constant area because there is a certain ground movement and you want the ground to move. So yeah, all of the options are correct. Again, that's the same. So we are seeing this relation like Ka by Kv. So these are the two types of sample. Again, it depends on your product of your Ma into Cv, volume of compressibility, as well as the coefficient of Cv value. So that's how you can evaluate the ratio K and K. Yeah, so the correct answer is 3.8. Again, for this you can use the same relation. So your t is directly proportional to u square, you can utilize this and calculate what is the additional time required for the 20% conservation. Yeah, and also these things we have addressed in our previous mm, set of questions. So again you have been given with a, I think that's the same data also. A little bit variation is there, but if you can refer question number 7 to 10, then you can solve this. So yeah, so I think there's no more audience, so we won't go further for our questions. So you can, for 18 to 20, you can refer back to question number 7 to 10, you can get an idea from there. And for another set of questions we have already solved this, so you can check the video. So those who are watching this video at a later stage, you can post your queries in the comment section of your this particular video. We'll address your query over there. And that's it for today. You can also post your doubt over there. So we are winding up for today. Thank you so much for joining. We'll meet at next Tuesday on same time.